All right, this is video number 5, and we are at the top of page 302. And just as a quick review, let's look at this diagram. When we are dealing with an angle bisector, as we are in this angle, we call all the points on this line the locus or set of all of the points in the interior of the angle that are equidistant from the sides of the angle. So remember, the locus is the set of all the points that meet a certain criteria. In this case, it's all of the points that are equidistant from the two sides of the angle. All right, so we are going to move to example 2, and we're going to be applying the theorem and the converse of the theorem that we learned having to do with angle bisectors. So our first job is letter A, and it is to find the measure of LM. So let's come back to the diagram. All right, looking at this angle JKL, we know that KM, line KM, is a bisector. We know that simply because the given or the drawn items are two arcs that show congruence. That means that this big angle has been cut in half and we have two smaller angles. If this bisector has cut it evenly in half, or if this line has cut it evenly in half, then it is in fact a bisector of this angle. So with that being said, we also know that all points along line KM are equidistant from the two sides of the angle. Therefore, JM is congruent to ML. If JM is 12.8, then ML is also 12.8. So that is the first answer for, sorry to put my finger in the way, for letter A. The distance of LM is 12.8. Now let's move down to B. We want to find the measure of angle ABD. And our given is given to us in words right after that, right here. It tells us the given is that the measure of angle ABC is 112 degrees. So let's look at this diagram. We are told that the measure of this big angle is 112 degrees. Now, do we know line BD? I'm sorry, that's actually a ray, and I called it the wrong thing in the previous example. This is ray BD, and what I'm asking is, do we know ray BD to be a bisector of angle ABC? Well, yes, in fact, we do. Using the converse of the angle bisector theorem, if a point on the line is equidistant from the two sides of the angles, then it does, in fact, bisect the angle. And with being told that, we know that it actually makes this angle congruent to this angle. So, if the whole angle measured 112, that was our given, then angle ABD, right here, which is what we're asked to solve, is going to measure 56 degrees because that is half of 112. So 56 degrees. All right, moving on to example C. Example C asks us to find the measure of angle TSU. Let's come over here and see what we can find. That is not the right one. There we go. TSU. We are looking ultimately for the measure of this angle right here. All right, so once again, we have to decide, is ray SU in fact an angle bisector? Does it bisect the bigger angle TSR? Well, the converse of the angle bisector theorem tells us that if point U is equidistant from this line segment and this line segment, or this ray and this ray, then this is going to be an angle bisector. And we can tell that this is equidistant to this because they have congruence marks. So therefore, we do know that ray SU bisects angle TSR. That means that this angle is going to be congruent to this angle. Now, if that's true, then we can solve for Z in these equations. Well, they aren't actually equations. They will be when we put an equal sign between them. But we can solve for Z in these binomials by saying 5Z plus 23 equals 6Z plus 14. And that is precisely what they did right here in your book. 6Z plus 14 equals 5Z plus 23. They solved for z, which is 9, but the question didn't ask for z, it asked for the measure of the angle. So now we must find that angle, plug the z back in, and we're done. So I think this is all fairly easy. You may have to use a bit of a thought process to be sure of what you're doing, but I don't think this is going to be super challenging. The next section may be a little bit more challenging, but we will end this one now.